Hey guys, so here we are, we're back. In the last video, we took a look at using the key pressed function to be able to detect keyboard input and specifically exactly what key is pressed. This is going to become very handy as we try to map different keys to different sounds as we progress with developing a soundboard. So what I'm going to do is I'm going to go ahead and open up in our sketches folder. I'm going to go ahead and open up the soundboard.js. Now this is the sketch that we're working on. So this is where we left off. We have the setup function, right? We're creating our canvas. We're making that black background. And we have our draw function, which is filling to some value, which is a variable that we set. We initialized it at 0. And then each time we press key code 68, which is mapped to the D key on our keyboard, we're setting a random value between 0 and 255. That is causing the screen to, whenever we hit the D key, to draw some random shade of gray square to the screen. Awesome. So now that we're doing that, let's start to think about what a soundboard would look like, right? A soundboard would basically just be a bunch of buttons, right? Like let's go ahead and pull up a picture of a drum machine, maybe. Let's see what a drum machine would look like. So a drum machine has a bunch of buttons on it. Let's just go images here. You know, there's a lot of different types of drum machines, but I'm thinking something like this, where you have these like pads here where you can just hit those buttons and they make certain sounds, right? Or maybe even better, something like this. Now we can experiment with the look and stuff like that, but the key point is that we're going to have this idea of a pad, right? So each one of these squares is a pad, and each one has specific functionality associated with it. Like when we hit one of the pads, it makes a sound, right? So let's go ahead and start to think about a pad in terms of a blueprint. Remember, when we talk about object-oriented programming, we define a blueprint to be able to actually make something. So in this video, what I'd like to do is, we're not going to get to the point of actually playing the sounds yet, but we're going to get to the point of abstracting this idea of a pad so that we can start to build this blueprint further to ultimately make sounds. So whenever we're thinking about a blueprint, whenever we're thinking about abstracting an idea, we could start to develop a class. So I'm going to go down here and I'm just going to type class pad. Now that is the start of a blueprint for a pad, right? Now, when we're talking about P5.js and just drawing on a canvas, we typically need to know the position of anything in the world. So the first thing we need to do is maybe keep track of the position. But before we even do that, let's go ahead and create that special function that we need to create that actually will turn the blueprint into an actual instance of a pad, and that is our constructor. So let's go ahead and type constructor, open, close. All right, did I spell that right? Constructor? I feel like I always spell that wrong. Constructor, right? And now within the constructor, we're going to go ahead and declare two variables. We're going to declare this.x is equal to, and we'll make it a fixed value for now, 10. And we'll say this.y equals a fixed value of 10. So now we have two local properties of this pad that declare two variables, which are x and y, right? Now, in order to actually see this pad in action, for it to do anything, we need to actually draw something to the screen. So I'm going to go ahead and outside the constructor, I'm going to create another function called draw. And now this draw function, again, this draw function, I just made up the name. Just because it's called the internal draw function of P5.js, it doesn't need to be that. It could be anything we want. I believe this is a best practice when we're talking about P5.js because it communicates exactly what this function does. It's going to draw to the screen, right? So within this draw function, why don't we draw a rectangle? So let's draw a rectangle. And we're going to draw a rectangle at this pad's X position and this pad's Y position. So we're going to use the pad's X and Y position, remember that internal property, to be able to place it on the screen. So we're going to draw a rectangle at X and Y, and we'll make it some fixed size. We'll say it's 25 by 25. Okay? So now, with that in place, we should be able to actually construct a pad. So now we have this idea of a pad. We know what it does. It draws a rectangle, and it draws a rectangle at a specific position in space using the X and Y internal variables. But now how do we actually use this bad boy? So now what we can do is we can instantiate or use that new keyword to be able to actually build pads. So why don't we go back to the top here and let's say our drum machine is just going to have one pad for the time being. We're going to say let pad 1, just going to say let pad 1. We're not going to actually initialize it up here just yet. We're just going to declare that we are going to create this variable pad 1 at some point. Now, within our setup function, we can go ahead and say right below this background black, we could say pad 1 equals new pad, open and close parentheses and semicolon. Now, this line is super powerful because what this just did was it said, hey, I want to construct a new pad based on the blueprint that we've defined using our class keyword. So we said a pad is constructed, and when it's constructed, it has an X and Y internal variable, or internal property, as we call it in object-oriented programming, and it also has a function or a method, which we call it an object, of draw, which draws a rectangle to the screen. So now at this point, after this line is executed, pad 1 is now an instance of pad, and we can call all of the internal functionality of pad, which means we can actually call the draw function, and we can actually draw the pad to the screen. So why don't we try to do that? So we can go ahead and we can draw it right here if we wanted to, or we could draw it within the P5JS draw function. So why don't we do that? I'm going to go ahead and I'm going to remove these two lines, and I'm going to say here pad1.draw. Now, what we expect to happen here is when this is called, when the draw function is called, which is called every 30 times per second, it's going to draw the pad to the screen. It's going to call this method and call rect at this X and Y 25, 25. Now, we don't have a fill defined anywhere, so let's see if we actually see anything. I'm going to go ahead and just refresh this. And there it is. So the fill is defaulting to white. So we see that our pad just rendered at the exact position we said, 10 and 10, and it's 25 by 25. So now if I change this, say for example, I change the X and Y to 25 and 25 and refresh this, you can see it's now moving, right? Let's make a more drastic change. Let's go 250 by 250 so you can really see that. And there you go. So now we have control over this constructed pad to be able to do what we need to do with it. Really powerful stuff. So now what we could do is, instead of having these fixed values in here, right? So we have this .x and this .y within this pad. Let's go ahead and make this more of a parameter so that we can, when we build a pad, we can build a pad at any position we want, right? Right now, this blueprint, the way the blueprint's designed is, anybody that comes along and says, hey, I want to build a pad, it's always going to be built at the same X and Y position. That's not good because there's no flexibility there in terms of how we want to build it, right? Typically, right, if I go back to the house example, if you're building a house, you probably want some flexibility as to, like, maybe I want to move a room around or something like that. You'd have to modify that blueprint to do that. In this case, with object-oriented programming, we can actually have inputs to the build process, and those inputs can then change the behavior of the instance of that class or the object that's built once we do it. Remember, there's that distinction between a class as a blueprint and the object as the concrete built structure after it's actually created. A really important distinction. So, to do that, what do you think we're going to do? We need to pass in parameters to the constructor function. So to do that, what we can do is we can go ahead and pass in two parameters here. And I'll just make them underscore x and underscore y, or we could just call them x and y. Right? Why don't we do that? Let's just make it x and y, not to confuse the characters, keep it simple. So now when we pass in x and y, we could say instead of 250 by 250, this dot x and this dot y is equal to x and y. So now we're taking these parameters and we're setting them to the internal properties of this class when we build the pad. Remember, this dot, that syntax here, this dot is referring to itself, right? It's like me being like looking at my finger and this is my finger, right? If you look at your finger, that is not my finger, right? That's your finger. So when we talk about this, we're referring to ourself. We're referring to the properties of ourself, right? So we're making the property of a pad that's built, this dot x, equal to the input of x and y that we bring in when we build it. Now we're not done here yet. In order to actually make this work, when we build the pad, when we actually say new pad, we now need to pass in the actual values we want to build it with. So now what we could do is we could say, hey, I want to build a pad, but I want this pad to be at x position 10 and y position 10. Now, if we refresh this, you'll see this pad is living at 10, 10. Now, and here's where the power comes in. Let's make another pad. So let's go ahead and create a pad 2. I'm going to say let pad 2 up here. And then here I'm going to construct pad 2 equals new pad. And now I'm going to make this pad, which is a completely different build. Think of it as a new house altogether, right? But we're using the same blueprint, but we're going to use different inputs. So I'm going to make this input 250 by 250. Now let's go ahead and refresh and see what happens. Do you think anything is going to be on the screen? Let's see. Nothing showed up. Why do you think that pad 2 is not drawing to the screen? We built pad 2, but we're not calling the draw method on pad 2. In order to get it to actually draw, to call that rect function, we need to call the draw method. So what we need to do down here in draw is go pad2.draw. So now we have two pads. We're calling draw for both of them. So we have two instances of the same blueprint, but we've passed in parameters that change where it's rendered to. So let's go ahead and refresh this. Boom. Now we have two different pads at two different places in space. That's kind of cool. So now, using this idea, we can manage variables that have specific builds of pads within them. So what we're going to do in class on Friday is we're going to extend this idea, and I'm going to introduce you to some of the core ideas with managing sound in P5.js. And we're going to look at how we can then take those sounds and make a pad specific to a sound so that when we hit a key, it plays a sound on a specific pad. All right, so play around with this idea. What I'd like you to try to do is maybe create a third pad. Try to create a third pad at a different position in space. How would you actually do that? And whenever you're thinking about this, always think about the class as a blueprint. And the blueprint contains two core things. It contains properties, which are internal variables. That's, in this case, this.x and this.y. And methods, which are internal functions. In this case, draw. And we can have as many internal functions and as many internal properties as we need to describe what we're trying to describe. And that's when we use the word abstract. We take an idea and we abstract that idea in order to define it within properties and methods. All right, guys? So give this a shot, and I'll see you guys on Friday, and we're going to continue to build on these ideas. All right, thanks.